Welcome to Universe Orbit, your gateway to exploring the vast wonders of space, where the mysteries of the cosmos unfold through captivating videos. Don't forget to subscribe so you never miss a single voyage through the infinite universe. The story of our solar system is a tale written in the language of cosmic time, spanning billions of years from the chaotic birth of stars to the serene orbits of planets that we witness today. To understand the solar system is to peer into the ancient past, to imagine worlds in formation, and to speculate on the destinies that await its celestial members. Long before the sun ignited as the brilliant star that now dominates the skies, a vast cloud of gas and dust drifted silently in the Milky Way. This nebula, composed of hydrogen, helium, and heavier elements forged in the hearts of earlier stars, was a primordial soup containing the seeds of planets, moons, asteroids, and comets. Gravity, the invisible sculptor of the cosmos, began to weave its subtle magic, pulling together pockets of matter until the densest region collapsed inward, eventually giving birth to our sun. The remaining material, swirling around the newborn star in a flattened disk, became the building blocks of the planets, asteroids, and other small bodies that populate the solar system. In those early times, chaos reigned. Planetary embryos collided, sometimes violently, merging to form larger worlds. In the inner regions, where heat was intense due to proximity to the young sun, only rocky planets could survive. Mercury, Venus, Earth, and Mars emerged from this crucible, dense and rich in metals and silicates. Farther out, where temperatures were low and ices could remain stable, gas giants like Jupiter and Saturn gathered massive envelopes of hydrogen and helium, their immense gravity shaping the orbits of countless smaller objects. Uranus and Neptune formed even more distant realms of ice and water, slower to coalesce, yet no less majestic in their silent grandeur. The solar system's past is not merely a history of formation, but also a saga of survival. The early Earth, bombarded by countless asteroids and comets, was reshaped constantly. These impacts delivered not only destruction, but also essential materials, including water and organic compounds that would one day foster life. The Moon, Earth's ever-present companion, was born from one of these colossal collisions, a cosmic remnant of a violent past. Meanwhile, Mars, once potentially warm and wet, experienced dramatic changes in its climate and atmosphere, leaving behind a barren surface that whispers stories of an alien world that might have been more Earth-like than today. The asteroid belt, lying between Mars and Jupiter, serves as a fossilized record of the early solar system. These rocky fragments, never assembled into a planet due to Jupiter's disruptive gravity, are remnants of the primordial material from which the planets formed. Farther still, in the icy outskirts beyond Neptune, lies the Kuiper Belt, a region populated by frozen worlds including Pluto, Haumea, and Makemake. Beyond the Kuiper Belt, the distant Oort cloud stretches like a vast, invisible halo, home to trillions of icy bodies that occasionally fall toward the sun as long-period comets, connecting the distant reaches of the solar system with the interplanetary realms. Time, in the cosmic sense, moves slowly, yet it is relentless. The sun, at its middle age, burns steadily, converting hydrogen into helium in its core. This ongoing process governs the solar system, dictating the climate and habitability of planets like Earth and shaping the destinies of the worlds that orbit it. Yet the future holds both promise and inevitability. In a few 100 million years, the sun's gradual brightening will alter Earth's climate, challenging life to adapt or face extinction. The orbits of planets, though stable now, are influenced subtly by gravitational nudges and perturbations. While catastrophic collisions are rare in the present epoch, they remain a possibility over immense timescales. In the distant future, the sun will exhaust its hydrogen fuel and expand into a red giant, swallowing Mercury and Venus, and possibly even Earth, leaving behind a transformed inner solar system. The outer planets, meanwhile, will drift in a slowly changing gravitational ballet, their moons enduring changes as tides and orbital resonances reshape their surfaces. Comets and asteroids wandering through the solar system will continue their long journeys, sometimes colliding with planets, sometimes being ejected into interstellar space. The fate of the solar system is intertwined with the life cycle of the sun, a reminder that celestial bodies are neither permanent nor immutable. While human understanding of the solar system is rooted in careful observation and exploration, it is only in recent decades that we have begun to witness its complexity firsthand. Robotic missions have visited every planet, revealing landscapes, atmospheres, and geological histories once accessible only to imagination. Rovers traverse Martian plains, orbiters study the turbulent storms of Jupiter, and spacecraft venture beyond the heliosphere into interstellar space, carrying the first whispers of our civilization into the cosmos. Each discovery reshapes our understanding of the past and offers glimpses into the potential futures of the planets and moons that share our sun. The interplay between cosmic chance and deterministic forces has sculpted a solar system of extraordinary variety. Venus, similar in size to Earth, evolved into a world with a dense, scorching atmosphere while Mars became a frozen desert. Europa, Ganymede, and Enceladus hint at hidden oceans beneath icy crusts, tantalizing possibilities for life beyond Earth. The tiny dwarf planets, though often overlooked, tell stories of formation and migration, evidence that the solar system has been dynamic throughout its history. Looking farther ahead, humanity itself becomes a factor in the solar system's unfolding narrative. Space exploration, colonization, and resource utilization will introduce new dynamics, with spacecraft, satellites, and human settlements becoming part of the cosmic story. The solar system that began as a chaotic swirl of gas and dust may one day host a network of human-made structures, altering its evolution in ways unimaginable to its original architects. The past and future of the solar system are bound together by cycles of creation, transformation, and decay. Comets that once delivered water and organics may continue to do so, potentially seeding life in unexpected places. Planets that appear stable now may experience upheavals in millions or billions of years as gravity, radiation, and cosmic encounters leave their mark. In observing the solar system, we are not merely looking at distant objects, but peering into the story of our own origins and the ultimate fate of the cosmic neighborhood we call home. Even in contemplating its vastness, one realizes that the solar system is but a single chapter in the epic of the Milky Way, which itself is one galaxy among billions. Yet within this relatively small sphere, spanning from the scorching proximity of Mercury to the icy fringes of the Oort cloud, we witness processes that mirror the evolution of the universe at large. The formation of planets, the birth of moons, the dance of gravitational forces, and the slow but inexorable changes driven by stellar evolution are all microcosms of the cosmic story writ large across space and time. Every crater on the moon, every canyon on Mars, every storm raging on Jupiter is a record of past events, a trace of forces that have acted over billions of years. By studying these features, scientists can reconstruct the timeline of the solar system, understanding how its planets formed, how atmospheres evolved, and how life on Earth emerged in a universe governed by natural laws. The future, while uncertain in its details, is guided by the same principles. Stars age, planets migrate, and small bodies drift, all under the influence of gravity, radiation, and chance encounters. As the sun transforms into a red giant, planetary atmospheres will be stripped or heated, oceans will boil or freeze, and moons may be fractured or lost. Asteroids and comets will continue their wanderings, some striking planets, others being flung into the void. Eventually, the sun will shed its outer layers, leaving behind a white dwarf, a dense remnant that will slowly cool over billions of years. The planets that survive this transformation will orbit a dim remnant of the star that once illuminated the sky, a quiet testament to endurance and change. Yet even as the solar system ages and evolves, the potential for new stories remains. The discovery of exoplanets in other star systems shows that planetary formation is not unique, and that life may emerge wherever conditions allow. Within our own solar system, icy moons, subsurface oceans, and distant dwarf planets offer opportunities for exploration and discovery, even as the sun's life cycle marches toward its inevitable conclusion. The past informs the present, and the present shapes our understanding of what may come. The narrative of the solar system is a reminder that change is the only constant in the cosmos. From the violent collisions that forge planets to the slow expansion of the sun, from the wandering of comets to the intricate dance of moons, every element is part of a dynamic system. Understanding this story allows humanity to appreciate not only the beauty and complexity of our celestial neighborhood, but also the fragility and resilience of the worlds it contains. In contemplating the solar system's past and future, one cannot help but reflect on our place within it. Earth is a product of billions of years of cosmic evolution, a small but vital part of a grand system governed by physical laws and chance and events. The past reveals how delicate the balance of conditions must be for life to emerge, survive, and flourish. The future reminds us that this balance is transient and that our stewardship of the planet, as well as our exploration of space, will shape the next chapter of this ongoing story. The solar system, with all its diversity and complexity, continues to inspire wonder. Its past is written in rocks, ice, and light years of orbiting matter. Its future will unfold according to the same universal principles that guided its formation. And in studying it, humanity gains both knowledge and perspective, understanding that while we are temporary observers in a vast cosmic drama, we are also active participants in the unfolding narrative of worlds, stars, and the vast emptiness that lies between them. As we peer through telescopes, send robotic explorers across millions of kilometers, and consider missions that may one day carry humans to other worlds, we continue to connect with the solar system in ways our ancestors could only dream of. Each discovery, from the geysers of Enceladus to the storm patterns on Neptune, adds detail to the intricate tapestry of history and possibility. The more we understand, the clearer it becomes that the story of the solar system is not a simple chronicle, but a living, evolving saga, one that stretches from the birth of the sun to the quiet remnants of its eventual demise, encompassing within it the potential for life, change, and renewal. The planets themselves are like living witnesses to the solar system's past. Mercury, the closest planet to the sun, is a scarred relic of early bombardment, its surface marked by countless craters that tell a story of violent collisions in the first few 100 million years of the solar system's history. Despite its small size, Mercury's iron-rich core suggests a dramatic past, perhaps one in which violent impacts stripped away much of its original mantle, leaving behind a dense world bathed in scorching sunlight by day and freezing cold by night. Venus, Earth's twin in size but vastly different in environment, hides its past beneath thick clouds of sulfuric acid. Its surface temperature is hot enough to melt lead, a stark reminder of how planetary atmospheres evolved in response to solar radiation and geological activity. Yet beneath that oppressive heat, the planet may harbor records of volcanic and tectonic activity that shaped its surface over billions of years. Earth, our home, presents a contrasting story. Its abundant liquid water, tectonic activity, and protective atmosphere are products of a delicate balance of factors, from its distance to the sun to the influence of the moon in stabilizing its axial tilt. Over billions of years, Earth's surface has been reshaped by continents drifting, oceans rising and falling, and ice ages sweeping across vast regions. Life itself has left its mark, from the earliest microbial mats to the complex biosphere that now thrives across the planet. The story of Earth illustrates not only the resilience of life, but also the fragility of planetary environments, a lesson for imagining the futures of other worlds in the solar system. Mars, the fourth planet, offers a glimpse into what might have been a habitable world. Ancient river valleys, lake beds, and minerals that form in the presence of water suggest a wetter past, a time when liquid water may have existed on the surface for millions of years. Today, Mars is a cold desert, its atmosphere thin and unable to sustain liquid water. But beneath the surface, evidence points to potential aquifers and ice deposits. The Martian moons, Phobos and Deimos, are likely captured asteroids, remnants of the same primordial material that built the planets, quietly orbiting their host and bearing witness to the solar system's turbulent history. The gas giants tell a story on a grander scale. Jupiter, the largest planet, wields gravity so strong that it has shaped the orbits of other planets and small bodies, acting as a cosmic shepherd. Its great red spot, a storm larger than Earth, has raged for centuries, a reminder of the immense forces at work in the solar system. The moons of Jupiter, particularly Europa, Ganymede, and Callisto, hold secrets beneath icy shells, with Europa's subsurface ocean emerging as one of the most promising places to search for extraterrestrial life. Saturn, adorned with its spectacular rings, is more than just a visual marvel. Its system of moons, including Titan, with its thick atmosphere, and Enceladus with its geysers, illustrates that dynamic, geologically active worlds are not unique to the inner solar system. The outer planets, Uranus and Neptune, inhabit the realm of ice giants, worlds composed primarily of water, ammonia, and methane ices with thick atmospheres. Their deep blue hues reflect the presence of methane in their atmospheres, while powerful winds and storms rage across their surfaces. These distant worlds have moons that are as intriguing as those of the gas giants, some potentially hiding oceans beneath icy crusts and demonstrating that even the most remote planets in the solar system can be dynamic and complex. Beyond Neptune, the Kuiper Belt and the scattered disk represent a frozen archive of the early solar system. Pluto, once considered the ninth planet, is now understood as one of many dwarf planets in this distant region. These bodies are remnants of the formation process, preserved in the cold darkness and far from the sun's heat. The Oort cloud, a hypothesized vast sphere of icy objects enveloping the solar system at distances up to a light year, serves as a reservoir for long-period comets, linking the inner and outer reaches of our cosmic neighborhood. Asteroids and comets are not merely passive relics. They are active participants in the solar system's evolution. Collisions between asteroids have created families of fragments, and impacts on planets have driven extinctions and reshaped landscapes. Comets, with their dramatic tails, carry clues about the primordial material from which the planets formed. When these icy travelers venture close to the sun, they sublimate, revealing their composition and offering scientists glimpses into the conditions that existed in the early solar system. Over billions of years, the solar system has experienced migration and rearrangement. Theories suggest that Jupiter and Saturn may have shifted positions, scattering small bodies and influencing the formation of the inner planets. Uranus and Neptune likely migrated outward, capturing and reshaping the Kuiper Belt and altering the orbits of dwarf planets. These migrations, occurring early in the solar system's history, have left imprints that scientists study to reconstruct a timeline of planetary motion and cosmic evolution. Looking into the future, the solar system will continue to evolve under the influence of the sun. Over the next few 100 million years, gradual brightening of the sun will increase surface temperatures on Earth, potentially triggering climate changes that challenge life. The orbits of planets, though largely stable, may experience subtle shifts over immense timescales due to gravitational perturbations. Occasionally, comets and asteroids will cross paths with planets, reminding us that cosmic hazards are an ongoing part of the solar system's evolution. In a few billion years, the sun will exhaust its hydrogen fuel and begin its transformation into a red giant. Mercury and Venus are expected to be engulfed, while Earth may experience extreme heating, potentially losing its oceans and atmosphere. The outer planets will remain largely intact, though their moons may experience altered environments as solar radiation changes. The fate of comets, asteroids, and distant icy bodies will continue to be shaped by gravitational interactions and occasional ejections from the system. After shedding its outer layers, the sun will become a white dwarf, a dense remnant gradually cooling over trillions of years. The solar system will persist in a quiet state, with planets orbiting a faint stellar remnant and distant icy objects slowly evolving under weak gravitational influences. Some may be captured by passing stars, others ejected into interstellar space. Yet the system will retain its structure for an immense period, a testament to the enduring nature of celestial mechanics. Humanity's role in the solar system adds a new dimension to its narrative. Space exploration, colonization, and technological interventions may alter the evolution of moons, asteroids, and even planets in subtle ways. Mining operations, orbital constructions, and planetary settlements will introduce human influence into a system that has evolved for billions of years without it. This intertwining of natural evolution and conscious action is unprecedented and adds a layer of complexity to understanding the future of the solar system. Scientific exploration has transformed our understanding of the solar system from myth and speculation to a detailed and nuanced picture of planetary formation, dynamics, and evolution. Observations, both from Earth and from spacecraft, have revealed geological processes, atmospheric dynamics, and the presence of water and organic molecules in multiple locations. Each mission, from orbiters to rovers and flybys, provides new data, enabling scientists to refine models of planetary histories and forecast future changes. The solar system's story is ultimately a story of balance and change. It illustrates how gravity, angular momentum, radiation, and chance encounters shape worlds over eons. It highlights the delicate interplay between catastrophic events and gradual processes that sculpt planetary surfaces and atmospheres. From the scorching plains of Mercury to the icy expanses of the Kuiper Belt, from active volcanoes on Io to potential oceans beneath Europa, the solar system embodies a dynamic equilibrium, a system in perpetual motion across space and time. Beyond the planets themselves, countless smaller bodies shape the solar system in ways that are both subtle and dramatic. The asteroid belt, long perceived merely as a collection of space debris, is actually a dynamic record of the early solar system. Collisions among these rocky bodies continue to produce smaller fragments, dust, and meteoroids that occasionally find their way to Earth. Meteor showers, the spectacular streaks of light across the night sky, are reminders of these interactions, tiny fragments blazing as they encounter Earth's atmosphere. Some impacts, particularly in the distant past, have had dramatic consequences, influencing the course of life on our planet, from the extinction of dinosaurs to mass extinctions of smaller organisms. Comets, icy wanderers from the outer reaches of the solar system, carry the story of primordial chemistry. As they approach the sun, they develop brilliant tails, releasing gas and dust that offer a glimpse into conditions from billions of years ago. These bodies are not merely beautiful. They are clues to understanding the formation of planets and the delivery of essential compounds such as water and organic molecules. It is possible that comets played a vital role in seeding Earth with the materials necessary for life, bridging the vast distances of the early solar system. The interactions between celestial bodies are not limited to collisions. Gravitational forces govern the intricate dance of planets, moons, asteroids, and comets. Jupiter, with its immense mass, acts as both a protector and a threat. Its gravity deflects some objects away from the inner planets, reducing the frequency of catastrophic impacts on Earth, while also sending others hurtling inward, a reminder that the solar system is a dynamic and interconnected web of motion. Resonances, where orbital periods align in simple ratios, sculpt the distribution of asteroids and influence the stability of moons. Even the distant Oort cloud is shaped by the gravity of passing stars and galactic tides, revealing that our solar system is not isolated, but part of a larger cosmic ecosystem. Looking far into the future, the evolution of the sun will define the ultimate destiny of the solar system. In about 5 billion years, the sun will exhaust its hydrogen fuel and enter the red giant phase. Its expansion will engulf the inner planets, transforming Mercury and Venus into memory, while Earth faces an uncertain fate. Oceans will boil away, and the atmosphere will be stripped, leaving a desolate landscape. This transformation, though catastrophic for life, is a natural progression of stellar evolution and illustrates how the sun's life cycle governs the potential for habitability within its system. The outer planets, however, will endure. Jupiter, Saturn, Uranus, and Neptune will continue their slow orbits around a swollen sun, their moons experiencing changes driven by increased radiation and gravitational interactions. Moons with subsurface oceans, such as Europa and Enceladus, may temporarily become more geologically active due to tidal forces, perhaps releasing new material into space. Distant icy bodies, once frozen in the darkness, may also experience changes, sublimating as the sun brightens, altering the composition of the Kuiper Belt in scattered disk. Eventually, the sun will shed its outer layers, forming a planetary nebula, and leave behind a white dwarf. In this final stage, the inner solar system will be a graveyard of planetary remnants, while the outer planets will continue to orbit a faint, cooling stellar core. Over trillions of years, the orbits of these distant worlds may be perturbed by passing stars, and some bodies may be ejected into interstellar space. The solar system, though no longer vibrant with a bright sun, will continue to exist, a silent monument to the processes of creation and transformation that shaped it. Even as the natural evolution of the solar system unfolds over billions of years, human activity introduces a new layer of complexity. The age of space exploration has already transformed our understanding of the solar system. Robotic spacecraft, orbiters, landers, and rovers have studied every planet and many moons, revealing diverse landscapes, atmospheres, and potential habitats. Observations of asteroids and comets have informed strategies for planetary defense, while missions to Mars, Europa, and Titan explore the potential for life beyond Earth. As humanity continues to venture outward, satellites, space stations, and even potential colonies may begin to influence the system in subtle ways. Mining operations on asteroids could redistribute mass, while orbital infrastructure around planets may change local gravitational dynamics over vast timescales. The concept of colonizing other planets raises profound questions about the solar system's future. Mars, with its frozen water reserves and relatively accessible surface, is a prime candidate. Terraforming, the hypothetical process of transforming a planet's environment to make it habitable for humans, is a distant but conceivable goal involving the thickening of atmospheres, warming of surfaces, and introduction of biological systems. Moons such as Europa or Titan may also become targets for exploration and potential habitation, though the challenges posed by radiation, extreme temperatures, and ice-covered oceans are formidable. These endeavors would mark a new chapter in the solar system's history, where intelligent life shapes environments rather than merely observing them. Beyond human intervention, natural phenomena will continue to influence the system. Collisions between asteroids or comets, though rare, can produce dramatic effects. Giant impacts could create new moons or alter planetary orbits subtly. Radiation from the sun and cosmic rays from the galaxy affect atmospheres and surfaces, slowly altering chemical compositions. Even the slow loss of planetary atmospheres to space over billions of years contributes to the evolution of planetary environments. The solar system is not static. It is a constantly evolving network of interactions, processes, and transformations. The solar system also interacts with the galaxy itself. As the sun orbits the center of the Milky Way, it encounters regions of varying stellar density, interstellar clouds, and occasional nearby stars. These encounters can perturb distant objects, potentially sending comets from the Oort cloud into the inner system. Galactic tides and passing molecular clouds may subtly influence orbital dynamics, reminding us that the solar system exists within a larger, dynamic cosmic environment. Over billions of years, such interactions could lead to the ejection of planets or minor bodies, altering the system in ways that are difficult to predict, but inevitable in the long-term evolution of the galaxy. The past, present, and future of the solar system are thus interwoven into a single narrative. Its formation was violent and chaotic, shaped by collisions, migrations, and accretion. Its present is a balance of gravitational forces, orbital resonances, and energetic processes. Its future, though distant, is governed by the inexorable evolution of the sun and the interplay of celestial dynamics. From the smallest asteroid to the largest gas giant, every component participates in a story that stretches across billions of years, offering lessons about resilience, transformation, and the impermanence of even the most seemingly stable worlds. The distant future of the solar system is a canvas for imagination and scientific speculation. Long after humans are gone, the planets will continue their slow journey around the sun. Earth, if it survives the red giant phase, may become an inhospitable desert, stripped of its oceans and atmosphere. Mars, too, may freeze further or be ejected from the inner system due to gravitational interactions over immense timescales. Yet even in this bleak scenario, remnants of life or chemical traces could endure underground or frozen in ice, a testament to the resilience of life and matter. The moons of the outer planets may hold surprises in the far future. Europa, Ganymede, and Enceladus, with their subsurface oceans, could experience temporary periods of activity due to tidal heating or changes in orbital resonance. These environments may remain habitable for microbial life for billions of years longer than the surface of Earth. Titan, with its thick nitrogen-rich atmosphere and hydrocarbon seas, may also provide stable environments for chemistry and potentially exotic life. In this sense, the outer solar system may outlast the inner planets as refugees for life, even if distant and cold. Comets and asteroids continue to play a subtle but crucial role in the solar system's evolution. Long-period comets from the Oort cloud will occasionally venture into the inner solar system, occasionally striking planets or being ejected into interstellar space. These icy travelers are carriers of primordial material, and their interactions with planets can deliver water, organics, or trigger changes in orbital dynamics. Even seemingly minor collisions can, over millions of years, alter the distribution of minor bodies and influence the structure of planetary systems. The Sun's evolution drives much of the long-term changes in the system. As it expands into a red giant, its luminosity will increase, heating the outer planets and distant moons. Some previously frozen worlds may experience temporary surface melting, creating transient environments that could support chemistry similar to early Earth. Eventually, when the Sun sheds its outer layers and becomes a white dwarf, the radiation environment will change dramatically, leaving a cold, slowly fading remnant star. Planets will continue orbiting, but the system will be quieter, less vibrant, and dominated by gravitational interactions rather than energetic processes. Humanity's influence on the solar system could leave a lasting mark. In the next few centuries, humans may colonize Mars, establish bases on the Moon, and even construct orbital habitats around planets or in the asteroid belt. These settlements will alter local environments, redistribute materials, and potentially change planetary surfaces. Terraforming projects, although far future concepts, might allow humans to transform portions of Mars or even moons like Europa, creating stable habitats where none existed naturally. In this scenario, intelligent life becomes a shaping force, altering the natural trajectory of celestial bodies in a system that has otherwise evolved over billions of years independently. Speculation about extreme cosmic events also illuminates the potential futures of the solar system. Nearby supernovae could bathe planets in radiation, stripping atmospheres or triggering mass extinctions on habitable worlds. Rogue planets or stars passing through the system could disrupt orbits, ejecting planets or minor bodies into interstellar space. Gamma-ray bursts from distant stars could irradiate planets, while collisions with large asteroids could recreate the catastrophic impacts that shaped the early solar system. Over timescales of billions of years, the solar system is both stable and vulnerable, a delicate balance between persistence and chaos. Even as we contemplate these extreme scenarios, the solar system remains a laboratory for understanding cosmic processes. The interactions between planets, moons, comets, and asteroids illustrate the principles of gravity, angular momentum, and orbital dynamics. Observing these processes allows scientists to reconstruct the past, understand the present, and make predictions about the future. Each planet, from Mercury to Neptune, and each small body, from Pluto to the smallest asteroid, is a chapter in a story that spans the birth of the Sun to the fading light of its eventual white dwarf stage. The potential for life elsewhere in the solar system adds another dimension to this narrative. Subsurface oceans on icy moons, thick atmospheres on distant planets, and even transient liquid water from comet impacts could create environments capable of sustaining life. Discovering life beyond Earth, even in microbial form, would redefine our understanding of the solar system, adding a biological dimension to what has largely been a geological and astronomical story. Human exploration in the coming centuries may finally allow us to directly investigate these environments, uncovering evidence that life is not unique to Earth. The story of the solar system is also a story of interconnectedness. Changes in one part of the system can ripple outward, affecting distant bodies over millions or billions of years. Jupiter's gravity influences asteroid orbits. Comets from the Oort cloud deliver materials inward. The sun's evolution alters climates across planets and moons. Even subtle effects, such as the gradual loss of atmosphere or orbital precession, accumulate over vast timescales, demonstrating that the system is a dynamic, evolving network rather than a static collection of objects. As the solar system ages, the remnants of civilization may persist. Satellites, space stations, and human-made structures could endure for centuries or millennia, orbiting planets long after their builders have vanished. The trajectory of humanity and its ability to influence the solar system may leave a faint but enduring mark in the cosmic record. In this sense, the history of the solar system is not only written in rocks, ice, and planetary orbits, but also in the traces of intelligent life that interacts with and alters its environment. The ultimate fate of the solar system, billions or even trillions of years from now, is a reminder of the impermanence of even the grandest structures. Planets may collide, be ejected, or slowly decay in their orbits. Moons may break apart under tidal stress. Comets may be lost to interstellar space. The sun will cool and fade, leaving behind a cold white dwarf that slowly radiates residual heat. Yet even in this distant, quiet future, the solar system will remain a testament to the processes that formed it, from the initial collapse of a molecular cloud to the complex interplay of bodies we observe today. Through studying the past and contemplating the future, humanity gains not only knowledge but also perspective. The solar system, with its diversity of planets, moons, asteroids, and comets, teaches lessons about creation, transformation, resilience, and impermanence. It reminds us that Earth is a product of billions of years of cosmic evolution, that life is fragile yet adaptable, and that our actions, even if temporary, contribute to the unfolding story of our celestial neighborhood. The solar system is, in essence, a story of transformation across incomprehensible spans of time. From its violent birth in a collapsing nebula to the serene orbits of planets we observe today, it has been shaped by collisions, migrations, and gradual processes of cooling and accretion. Each planet, moon, asteroid, and comet carries within it a record of these events, a silent witness to a history billions of years in the making. Yet even as we explore the past, we must recognize that the solar system is far from static. Its present is a dynamic interplay of gravitational forces, atmospheric changes, and ongoing chemical evolution, all of which continue to reshape its landscapes and environments. Looking forward, the future of the solar system is defined largely by the life cycle of the sun. As it ages, the inner planets will face increasing temperatures, loss of oceans, and potential atmospheric collapse. The outer planets will endure longer, yet even they will experience subtle changes as tidal forces, solar radiation, and orbital perturbations influence their moons and ring systems. Icy bodies in the Kuiper Belt and Oort cloud may be nudged into new trajectories, occasionally sending comets into the inner system. These interactions, though slow on human timescales, remind us that the solar system is a system of constant motion and change, a network of interdependent bodies responding to physical laws and chance encounters. The possibility of life beyond Earth adds a layer of profound significance to this narrative. Moons such as Europa and Enceladus, with their hidden oceans, may harbor microbial life that has endured far longer than life on Earth. Titan's exotic chemistry, under a thick atmosphere of nitrogen and methane, may support prebiotic or entirely alien forms of life. Comets and asteroids could deliver essential compounds across planets, seeding environments that may be conducive to biology. The study of these worlds not only informs us about the origins of life on Earth, but also expands our understanding of where life might exist in the cosmos, turning the solar system into a living laboratory of possibility. Humanity's influence on the solar system, though minuscule compared to cosmic forces, is nonetheless historically unprecedented. In a few decades, we have moved from observing planets as distant points of light to sending robotic explorers that traverse their surfaces, orbit their bodies, and even leave our solar system entirely. In the centuries to come, human settlements, orbital structures, and perhaps terraforming projects may introduce long-lasting changes, embedding traces of intelligent life into the very fabric of the system. This introduces a unique interplay between natural evolution and conscious action, where a species can actively shape its cosmic neighborhood. The solar system, in its vastness and complexity, is also a reminder of our perspective within the universe. Earth is a single planet orbiting a single star in one of billions of galaxies. Yet within this relatively small system, we find extraordinary diversity: molten cores, icy moons, raging storms, barren deserts, liquid oceans, and delicate atmospheres. Each world, no matter how distant or small, contributes to the grand narrative of formation, evolution, and potential renewal. It is a story of balance between order and chaos, of forces that can both preserve and destroy, and of timescales so immense that human history occupies but a fleeting moment within them. In contemplating the past, we see the solar system's violent beginnings, the collisions that created planets and moons, and the migrations that sculpted orbital structures. In observing the present, we witness stable yet dynamic orbits, ongoing geological processes, and the interplay between light, gravity, and chemistry. And in imagining the future, we confront the inevitability of change, the sun's transformation into a red giant, the possible demise of inner worlds, and the enduring dance of outer planets and distant icy bodies. These reflections allow us to appreciate the delicate conditions that allowed life to flourish on Earth and challenge us to consider our role in shaping the system's ongoing story. Ultimately, the solar system is more than a collection of celestial objects. It is a living chronicle of cosmic evolution. Its past provides context for our existence. Its present offers a laboratory for discovery, and its future challenges us to consider the legacies of both natural forces and intelligent life. By studying its planets, moons, asteroids, and comets, and by imagining the paths they will follow over billions of years, we deepen our understanding of the universe and our place within it. The solar system teaches us that change is inevitable, yet even within impermanence, patterns of resilience, adaptation, and interconnectedness emerge, offering both humility and inspiration to those who observe it. In this grand narrative, humanity is a new participant, capable of exploring, understanding, and influencing worlds beyond its own. The search for life, the expansion into other planets, and the careful observation of cosmic phenomena are threads in a story that began billions of years ago and will continue long after we are gone. The solar system, in all its complexity and beauty, is at once a relic of the past, a stage for the present, and a canvas for the future. A reminder that in the vast expanse of time and space, even the smallest actions can ripple across the cosmos, leaving traces that endure long after we ourselves have vanished. As we look outward to the distant planets, moons, and icy bodies, we are not merely studying rocks and gas. We are reading a history written in motion, collision, and transformation. We are witnessing a system in constant evolution, a delicate balance of forces that has persisted for billions of years and will continue for billions more. In understanding the past and anticipating the future of the solar system, we gain insight not only into celestial mechanics and planetary science, but also into the broader narrative of the universe, where creation, destruction, and renewal are interwoven in an endless cycle of cosmic evolution.